All right, so continuing with partial fractions, we talked in the first video, kind of the motivation behind this. What kind of functions are we looking at? And we also saw an example where when we are breaking the function up into partial fractions, we only have distinct linear factors in the denominators. So now we're going to see when we have repeated linear factors. So this could look something like, we'll just make one up. So let's say 3 over x plus 4 times x plus 1 squared. So now the x plus 1 is repeated. So now if we break this up, it's going to have the form a over x plus 4 plus b over x plus 1. And then we're going to have another one to account for the repeated factor. So whatever that exponent is, you're going to have that many factors, and we're going to keep adding an x plus 1 in, or multiplying by x plus 1, I guess you could say. So if there's a 3, we'd have x plus 1 squared, x plus 1 cubed, and then it's always just a, b, c, d, however many you have along the numerators. All right, so let's see how this works. I think this is number 3 in the notes. So we have the integral of x to the 4th minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1 dx. Okay, so remember from the first video, the first step is to, check the degrees. So in this case, the degree in the numerator is bigger than the denominator. So we need to divide, long division, the denominator into the numerator. So let's do that. And we did one of these in the first video, so if you need another review, you're going to get it. We don't have an x cubed term, so we need to have a 0x cubed there. Minus 2x squared plus 4x plus 1. All right, so x cubed goes into x to the 4th x times. Multiply x times x cubed and so on. So we get x to the 4th minus x cubed minus x squared plus x. Then we subtract 0 out, and then we get x cubed here. Negative 2x squared plus x squared, so that's a minus x squared, 4x minus x, so that'll be a 3x, and then plus 1. All right, x cubed divided into x goes once, and then we get x cubed minus x squared minus x plus 1, and then we're going to subtract again. Zero's out, 3x plus x gives us 4x, and then 1 minus 1. So we end up with x plus 1 as a quotient, 4x is the remainder. All right, so now this becomes x plus 1 plus 4x over the original denominator, x cubed minus x squared minus x plus 1. Okay, so now step 2 is we need to factor the denominator. So we have, obviously we don't need to do anything with the x plus 1 anymore. So we can factor this by grouping. So we can factor out an x squared, and we're left with x minus 1. So we're factoring by grouping. So group those two. Now these two, we can factor out a negative, and we're left with an x minus 1. Then keep going. So we have x plus 1 plus, now when we factor by grouping, now we're going to factor out, so we have this term and we have this term. We factor out an x minus 1. And we're left with x squared minus 1. And that's all over 4x dx. And now we can factor x squared minus 1, x plus 1, plus, we got x minus 1, x squared minus 1 factors x minus 1, x plus 1. And that's all over 4x. Okay, so now we have completely factored the denominator. Let's rewrite it. We'll combine the x minus 1s. So x minus 1 squared, x plus 1 over 4x dx. Okay, so now let's set up our partial fractions here. So we have 4x over x minus 1 squared x plus 1, and we're going to set it up the way we did up here. So we're going to set it up in this way. So we have a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. Okay, so I'll do this one. So now we need to figure out what A, B, and C are. I will do this one the way I normally do these. I probably do this way more often. But you can do the matrix way where you set up the system of equations like we did in the last example, or you can do it this way. Sometimes this way is a little bit more tedious, I think. In this case, when you just have linear factors, it's usually not too hard. So the way you can do this, first of all, we need to get the common denominator over here, and then we'll set the numerators equal. So the common denominator is this guy. So we need to multiply this first term by x minus 1 and x plus 1. So we got to multiply by x minus 1 because the common denominator has x minus 1 squared. We only have an x minus 1 to the first. So you got to add in the extra x minus 1. Then the b term, we already had the x minus 1 squared, so we just have to put in the x plus 1. And in the c term, we have the x plus 1. We're missing the x minus 1 squared. Okay, so now we need to figure out what a, b, and c are. And so the other way to do this, from the way, besides the way we did it in the last example, is this is an identity. So this will work for any x. This will be true for any x. So pick any x, and then we'll see what happens. Now you can pick any three x's, and you will get a system of 3 equations. But you can also be a little bit more strategic and solve it without using a system. So what do I mean by that? If we pick x equals 1, let's see what we get. So 4 times 1 is 4. A times 1 minus 1 times 1 plus 1 plus b times 1 plus 1 plus c times 1 minus 1 squared. So that term is going away. That term is going away. And so we end up with 4 equals 2b. So b equals 2. Okay. And that's how we're going to go about this. So now let's rewrite this one. We'll fill in the b. And you could FOIL this out if you wanted. It's not really necessary one way or the other. Doesn't matter. The only way, you might do it just so you don't have to rewrite that whole thing every time. All right, now what's another convenient term we could pick? Well, so the idea is you want to zero out at least one of your terms if possible. So if we pick -1, that will zero out a couple of terms. So you have -4. This one is going to go away because when you plug an x there, you get 0. This will go away because when you plug in -1, you get 0. And so we end up with c times -2 squared, which of course is 4, and that gives us c is -1. All right, now we just need to figure out what a is. So we have 4x equals a times x squared minus 1. I'll multiply these out. Plus 2 times x plus 1 minus, c is -1, so minus x minus 1 squared. Okay, so now you can really pick anything besides positive or -1. We can pick 0 if you like, or any other number. Any number will work. So we get 0 equals, this would be -a. this would be plus 2, and then this would be minus 1. So we get 0 equals negative a plus 1, so then a is going to be 1. Okay, so now we can rewrite our integral. So we're going to rewrite this in terms of our a, b, and c here, where we have it like this. Okay, and let's not forget our x plus 1, so we'll go ahead and write that too. So the integral x plus 1 plus 1 over x minus 1. B is 2, so that would be plus 2 over x minus 1 squared, and then c is negative 1, so minus 1 over x plus 1 dx. And now it's fairly easy. So let's look at integrating this. So we have 1/2 x squared plus x plus ln x minus 1. Now, this is the only one that may trip you up a little bit. If you like, you could make this, you could do a u substitution. This is a fairly simple one. But really, since this is just x, and the constant doesn't really matter as far as the integrating goes, so this is a negative 1, so let's add 1, or negative 2, so let's add 1, which gives us negative 1, so this will be 2 over x minus 1. And then minus ln of x plus 1 plus c. And there you go. All right, so clearly these can take a little while. And a lot of places to make mistakes. So be careful. Like I've said in other videos, try not to do too much all at once. It might not be a bad idea when you're doing these steps to plug in, like don't try to skip too many steps, because if you get these wrong, a, b, and c, obviously everything's going to be wrong after that. And you can, once you get your answer, you can take the derivative of this and see if you get back to where you started, but that is also very tedious and will take several minutes to do. So it's not the easiest process in the world. You need to learn the process very well and then be very careful. I mean, that's about the only way around it. It's gonna take a while. It's not, it's not gonna be quick. So be careful is my good advice, I guess.